You're on.
Great. Hello again, everybody.
All right, great. We'll get started. So first, I guess we had the Argentina-Switzerland game, 1-0, great. Now the U.S. game is on. I promised to weave in the stream of the video in my demo, so if we could not stream, that would be great. Just to get started, I wasn't sure if everyone had watched the first demo we did in the application spotlight, but I want to give you a quick overview of who we are, what we do at Zoomdata, what our mission is, and then from there, we're going to go deeper into the architecture of Zoomdata, what it is that we built behind the scenes that will allow the flexibility that you'll see through the demonstrations. Then we'll talk about why we're excited about the Spark project as well as the work that the Databricks team is doing. And then we'll talk about some of our current experiences working with the latest code base from Spark, and then talk about what are the things that you could expect from us in our coming releases. And then from there, I'll dive into some demonstrations of things that we are able to do on top of Spark as well as other ecosystem of data. As you guys had seen earlier on, the mission at Zoomdata is to change the way people see and interact with data. And when we look at data, that data can sit in a variety of stores, whether it's on the cloud or on premise, whether it's streaming or batch-based, whether it's in relational or non-relational sources. From a visualization perspective, we want to make it beautiful and intuitive. We want people to not only be able to visualize and make decisions, but also contribute to the way that data can be represented in an art fashion. And lastly, as we look at devices, our philosophy is that the next generation of devices are here now. We're no longer dependent on the keyboard and mouse, although we do need to support it. There's touch-driven devices. There's also the augmented reality coming with Google Glass and other wearables, as well as the virtual reality coming with Oculus Rift and other devices like that. So at Zoomdata, what we want to do is, keeping these three principles in mind, we want to build an interface for the everyday business user to be able to explore their data without any programming. With that said, I'm going to now turn it over to Justin, who's going to go over the architecture of Zoomdata and what we've built over the last 2 years.
Great, thanks, Farzad. I'm just going to talk for a bit about how we've architected Zoomdata and some of the architectural decisions that we've made along the way. We started out focusing on real-time stream processing, and we initially started using the Storm open source stream processing engine. And in terms of our goal of building a business intelligence type tool, we need to support lots and lots of concurrent users. And one issue we ran on right away with Storm was that as soon as we ran more than a few topologies in parallel on a given server, the server would crash because we ran out of threads. So we moved to, in the pre-Spark streaming as far as I know days, we moved to kind of a tightly coupled Storm type spout and bolt type topology, but wrapped it inside our Zoomdata server. So stream processing engine was kind of the original piece of Zoomdata and is still kind of the heart of our Zoomdata system. And we're currently investigating the use of Spark streaming for parts or potentially all of our stream processing that we do inside Zoomdata. But originally when we started architecting, we were focused on real-time streams of data, which of course led to the stream processing capabilities, and we were doing real-time visualizations. But then our customers and prospects started pointing out that they had lots of historical data as well. And we initially tried to support that historical data by simply restreaming it through the stream processing engine. And we realized that that wasn't the most efficient way to do it, and that instead we could push down a lot of the analytics into the back-end systems, be it a database or be it a Hadoop system or a SQL on Hadoop type interface, or even search engines like Solr and Elasticsearch have faceting capabilities. And this allows us to push as much of the work as possible down into the actual data storage mechanism where supported. So we started building up a library of connectors to things like MongoDB, Solr, Elasticsearch, various databases, et cetera. And what we then realized is that we could leverage our stream processing engine even against huge amounts of historical data by effectively running streams of little tiny queries against these back-end data stores, and then stream processing the results of these little tiny queries through our existing stream processing engine. And that allows us to visualize what would normally take a lot of time or huge amounts of data. It allows us to visualize it almost instantaneously, as Farzad showed earlier in the demo, and we'll show a little bit more of in a few minutes. So that's how we approach historical data, and that lets us also fuse real-time data together with historical data. And we're excited about Spark. If you go to the next slide, please, Farzad. We're excited about Spark because it's going to be a core piece of our what we call our data fusion fabric. We heard this morning from the gentleman from SAP about corporate kind of data fusion, and we agree with that kind of concept. Our philosophy is leave the bulk raw data, leave it raw, and leave it in the kind of best final resting place that it belongs in, given its type of search type data. Unstructured data maybe belongs in a search type index, or structured type data maybe belongs in a structured repository. And we want to leave the data there and then run the analysis against it, but then be able to fuse the results together, even across disparate sources of data. And we need to do this in a way that is, as we mentioned, very, very easy for a normal human user to interact with. And Spark and Databricks' new product give a lot of this kind of capability to a more advanced kind of data geek or data scientist type user. And our goal is to leverage the power of those kinds of systems, bring it to the normal business people. So we're leveraging Spark as the foundation of our data fusion fabric. And we also have a connector, as Farzad mentioned and demoed, and we'll demo in more detail in a moment, to Spark and to Databricks. So whether you're using Spark on a Hadoop system, Spark standalone, or Spark through the Databricks cloud, Zoomdata is able to connect to those data sets stored in Spark, and particularly when using SchemaRDD, which we'll talk about in a bit more detail, able to immediately pick up and start visualizing and fusing data together from those kinds of sources. The other note on the top is we've wanted to have a math studio, we always have called it in our product, to allow for machine learning and to allow for more advanced manipulation of data. And when we started working with Databricks a few months ago and we saw their notebooks feature, we realized that that Databricks notebook interface would be a perfect fit for what we'd always wanted to build in our math studio. So that's another reason we're excited about working not only with Spark, but also specifically with Databricks. Can you go to the next slide, please? So in summary, why we're excited about Spark is it's obviously fast, it's distributed, lets us fuse data together, and also the flexibility of language, which all of you know about. I personally was very shocked when I started learning Scala a few months ago by what I could do with a single line of Scala. It was a very long line of Scala, but it would have taken me hundreds and hundreds of lines in my prior programming life. And the integration with the open source and otherwise machine learning and statistical packages is a huge benefit for Zoomdata and for our users, because we can leverage models that more advanced users have created and apply them and really visualize the output of them to the more normal business people. Go to the next slide, Farzad. So we're using Spark to do a couple things. When we're using legacy databases, sometimes the queries are very slow. So we're using Spark to hold kind of raw data sets in memory for really, really fast analysis. When dealing with larger databases, such as more scalable back-end data stores and data warehouses, we are able to run aggregate queries or create cubes effectively from those back-end data stores and then hold those cubes in Spark for very, very rapid visualization, and also to then fuse across disparate sources. If we have an understanding of the data that's in those different places and how it joins together, we're able to fuse it together and do joins across sources that normally can't be joined together. And the complex math I mentioned before as well, in terms of leveraging other projects on top of Spark. So benefits to us is lets us point to data that's raw in Hadoop or S3 or HDFS or other file systems. Now with the support of Cassandra and some other things, we're able to extend the reach of Zoomdata very, very easily just by going through Spark. It levels the playing field for the slow and the untuned data warehouses and the legacy data stores that still represent a huge amount of corporate data. And it lets us fuse together data not only from different sources, but different types of sources, such as data that's in search repositories, unstructured document stores, key value stores, as well as traditional data warehouses. The benefits of Databricks to us we've experienced this very ourselves just over the last few weeks of playing with their interface, is we're able to spin up various size Spark clusters almost instantaneously. That allows us to profile different types of operations and different types of sizes of data sets very quickly. It used to take us a long time to spin up new instances of Spark and set up new clusters. And the Databricks ability to quickly spin up clusters is, and then for Zoomdata to therefore connect to them has been really fantastic. I mentioned the Math Studio, and the direct access to RDDs is fantastic, especially as we migrate to SchemaRDD, and I'll talk about that on the next slide, I think. Before I do that, so some of the things Farzad will show you is that we're doing things like progressively loading data into Spark, so not just loading it in one batch from a SQL query, but breaking up that query into lots of little tiny queries, and then effectively stream loading the data into Spark to allow for more quick initial analysis when pointed to a backend data store. And the data sharpening, Farzad will show you in the demo, the ability to kind of start initially showing data that's initially sampled, but then gets clearer and clearer the longer you watch, and that sample to full, and Farzad will show you that as well. So in terms of hurdles we're facing with Spark right now that are going to get better, obviously, is we are just now switching to Spark 1.0. We are trying to figure out the best way to share Spark context across Zoomdata servers. So Zoomdata requires, when being used with a huge amount of users, a large number of Zoomdata servers clustered together. And we need those Zoomdata server clusters to be able to share a single Spark context so they can access the same stored RDDs. And the same issue applies for sharing RDDs across Spark contexts. So if we have data that's in different Spark contexts, we need to be able to kind of share those RDDs across those contexts. And Tachyon helps a little bit with that. We've done some profiling and testing of Tachyon, but we're not quite sure that it's the solution, at least as it exists right now. In terms of SparkSQL, we've run into just a couple kind of small issues in our initial work with with SchemaRDD in particular, and with SparkSQL as well. Zoomdata before recently didn't use SparkSQL and doesn't use Shark. We found Shark to be much too slow. So we did native operations across the RDDs that we've been seeing in our demos. But with SchemaRDD, again, we're very excited about it. And with SparkSQL, we found that some things like offset is not yet implemented. Partitioned Parquet files are not cacheable. We run into some data type support around the int96 data store data type, which is what Impala uses as a date timestamp, which is important for our kinds of use cases. And also the persisting of Parquet files in memory is not working quite yet as far as we can tell, but I'm sure those will get better as we all work together. So Farzad, time for the demo.
Sure, thank you. So what I'd like to do now is go ahead and switch over to the Zoomdata interface. So let me go ahead and put this into presenter view. Here we go. Wait 1 second. Here we go. So as you can see here, this is the Zoomdata interface. I showed earlier, we support a variety of data sources, and 17 of them, and we're continuing to add to this. In addition to connecting a variety of data sources, we actually have a very pluggable studio from a visualization perspective. So we do have some charting out of the box, but our philosophy is that there are some really incredible JavaScript frameworks out there that some developers like to continue to stick with, and also for us to keep the flexibility of, let's say if we want to build a, which we build a demo on the Oculus Rift, we may want to use some WebGL or some other 3D types of frameworks. We want to be able to expose that on the sort of like post installation and allow people to reuse those types of libraries. And as you can see here, I'll show you an example of one where we've built a sunburst visualization. So again, a developer is able to code their visualization. They could import any library they want. We have some out of the box. You could bring in your own libraries. What Zoomdata does is it abstracts the hard stuff, right? So as a front-end developer, you don't want to worry about bringing all of the data to the web browser. You don't want to worry about where the data is sitting. So we sort of abstract all of that out and give you a set of APIs to work with, as well as a variety of set of controls, whether you want to do filtering, switching, group bys, etc. And then from there, the developer can go ahead and develop any type of visualization that they want with it. So what I did was then actually building on the Twitter demo that I showed earlier, we went ahead and built a visual that streams the game. So if this works, we should be able to see the game streaming here. And side by side, we're going to see basically the tweets that are coming in about the US-Belgium game. So again, probably a little bit hard on the bandwidth. But again, here you'll see once this is up, the game is going to be playing. Actually, I might have had it. Yep.
I think it's halftime, Farzad.
Okay. So you guys get the idea in terms of how you can use the Visualization Studio. Now, if we go underneath the hood, you'll see that there's a variety of connectors that we have here. We talked about the Databricks connector and the ability to be able to plug and play with your clusters. Again, these are all sort of work in progress. So what I'm showing you are sort of things that are coming in our future releases as we work on the integration path. But the idea is that you could spin up your clusters if you wanted to on the cloud through the Databricks interface. You could point data to your files, and then from there be able to explore them in Zoomdata. In addition to that, what I've also wanted to show you guys our micro-querying technology. So in the case here, I'm actually going to go into a 1 billion record set sitting in Impala. So again, as you'll see here, I'm going to go ahead and go on some drill down. So I'm going to go into categories, and you'll see a percentage here. So it's almost like video streaming. If I'm streaming HD, it's going to start out a little bit fuzzy, and then it's going to sort of, as the pixels come in, build up into a full resolution. Same concept applies here. So as I'm changing the group by here, we're issuing a bunch of queries against the Impala cluster. And as the results of those queries come back, we start projecting the final results. So again, even though this query is still running, I can kind of get an idea of what the sale, in this case, what are the volumes by the product category. And while even those queries are occurring, I can go ahead and start drilling and exploring the data. Now, we've also built something similar as this in the sense of loading data. So what I want to show you guys is actually loading data from an RDS table, 500,000 records in this case, into a Spark cluster. And while that table is loading, I'm actually going to switch into a visualization so you could see the results through that progressive loading. So what I'll do here is I'm going to go ahead and use the RDS connector, give it a title. I'm going to connect into my RDS source. Here I can view what I have access to. I'll select the 500,000 records. Again, Zoomdata sort of profiles the data from the schema, and that's it. So I've set up this source. I can go right away into it and go ahead and run a bar chart. And what you'll see is as the data is getting loaded into my RDD, I'll see the results. So in this case here, that data has been loaded now. And again, I'm able to explore and interact with it similar to what I had shown you guys earlier. And then the last piece I wanted to show was our pivot table. So again, looking at that 40 million record set that we had held in a cluster in Databricks, what I could do is actually go ahead and point to it. So again, here I have a similar sort of functionality as we see in Excel or other BI tools, where I have the ability to drag things around. I can go ahead and add another group by. Let's say as this is loading, I may want to change the volume and look at it by actual sales. And then as this information is coming in, I'll get to see the visualization on it. So again, the idea is that very interactively, I can go ahead and explore the data and not only look at a specific data source, but as I build my dashboard, I can start bringing together data from a variety of stores. So in this case, I'm looking at data sitting in Spark. I can go ahead and bring in my data sitting in Impala, go ahead and bring in my tweets coming in about the game, and also look at the UFO sightings that I have on the other data set. And then once I'm in my dashboard mode, I can go ahead and explore it, interact with it, look at a specific one, change colors, and go back. And then once I'm done with it, I can go ahead and save it, and anything you save can either be shared with other Zoomdata users or be embedded as iframes into your website. We also have a couple of other things I want to show you quickly. So you may want to know, how do I get access to Zoomdata? If you go into our website, we actually have a download section where you could download the server. It's available as an RPM or a .deb, as well as a VirtualBox and VM. We actually have a Docker container, if any of you are interested to pull that in from Docker. And also on GitHub, what we've done for our 1.4 version, which was just released, we have introduced the JavaScript SDK. So what you're able to do is not only embed iframes into your application, but you could actually build natively using your websites or portals and embedding our visualizations and controls in it. That's all I had from a demo perspective. What we'd like to do now is open it up to the floor for any questions that you may have.
All right.
Yeah, could you guys talk about how you're streaming SQL and RDS sources into Spark?
Sorry, the question is, how do we pull the RDS tables into Spark? Or?
Yeah, how are you like streaming replication?
Okay. How do we stream the?
Yeah, so are you using like MySQL replication with like a connector to that and putting that into Spark, or how does like RDS and MySQL data get into Spark like live?
Sure. So once you have your Zoomdata instance set up, what you could do is, so for example, for the RDS, all you have to do is specify, so in this case, let me set up a test account. What we need to know is basically how to connect through the JDBC URL into your RDS instance, and from there, by giving us the credentials to be able to link in to it, then we're able to read basically what tables are available. And at that point, we don't have to bring it to Spark. We could just issue queries against the RDS instance. Or what we could do is, and that's what I was showing in the demo, is, so here I have the ability to say, I'm going to issue queries against it. Now, there may be performance issues. You may not have an index on time or et cetera. But what you could do is just sort of flag it as, you know what, I'm going to bring this into Spark. Now, underneath the hood, you have to specify where your Spark cluster is. So either that could be sitting in your Databricks account, or you could have a local Spark instance that you want to connect to. And essentially, you tell Zoomdata where that Spark cluster sits. And then Zoomdata will handle the creation of the RDD from that table. Does that make sense?
So Zoomdata is issuing the queries directly, and then Zoomdata is creating little RDDs and then fusing them together as the data comes back from, this case, MySQL and RDS.
No problem.
We have time for one or two other questions.
I come from a security background, so one of the issues we have is, do you have like things like Kerberos authentication and stuff like that handled? Because every time we go to a visualization vendor, this is one of the problems we always face, that they cannot get past the authentication at all. So do you have, can you do that?
Yeah, so the question is, when it comes to Kerberos, I guess specifically from a security framework, do we have any issues working with secured clusters? So in addition to being certified on Spark, we're also certified on CDH. And as part of that, we actually had to certify that we're able to connect our Impala connector as well as Cloudera Search to a Kerberos setup cluster. So we've been able to accomplish that. So you could basically query data sitting in Impala or your search index in CDH on a Kerberos setup cluster.
And that includes support for Sentry as well.
Yep.
Is there any other questions? Okay, the last one.
So is there any caching mechanism? Do you go to the data source every time, or do you cache it, and how does the caching work?
Sure. So the question is, do we always query the data or the data store underneath, or do we cache it? We actually have two caching strategies. So one is we use Hazelcast on the server side for memory cache, and then also Spark is another cache of ours. So if you look at the data source setup here, you'll actually see a cache column, and in there we specify in the cases of, and you have an option. So when you set up your data source, you could say that I want this cache or not, and then Zoomdata is able to leverage either the Hazelcast cache, which is internal to us, or Spark for flat files and SQL-based data stores.
Thank you.
Thank you.
Thank you, everybody.